Hi, I'm Jake from Jakeology. Today we're going to talk about... Wait, do you hear that? Ah! Waves. Let's get nerdy. What is a wave? A wave is a disturbance that carries energy. There are all kinds of waves. Light waves, sound waves, seismic waves, ocean waves, ultrasound waves, microwaves, radio waves, and of course, a stadium wave. The two main types of waves, though, are longitudinal and transverse. I'm going to be showing you both kinds. Let's start with transverse waves. A transverse wave is a wave in which the motion oscillates along paths at right angles to the direction of the wave's advance. What in the world does that mean? Well, I'll break it down for you. That means that if the wave is heading across, then the parts of the wave will move up and down. Transverse waves have certain things in common. Every transverse wave has a high point called a crest and a low point called a trough. The height of a wave from the center line to its crest is its amplitude. The distance between waves from crest to crest or trough to trough is its wavelength. Let me show you a model of a transverse wave using bamboo skewers and Sour Patch Kids. First, I set up 2 chairs and put duct tape on them with the sticky side up. Then I put equally spaced marks on the tape. Now here comes the violent part. We're going to take some Sour Patch Kids and just squeeze and just put them in between the skewers. And then we're going to put them on the dark spot. Let's skip this part. I'll see you when these are done. So, welcome back. I present to you Skewered Sour Patch Kids. Just ignore that. And our next step is to give it a tiny little bump. You can see the energy of the waves passing along the tape. The skewers aren't traveling, they're just moving up and down. While the energy is moving in a forward direction, that's how transverse waves work. Now let's take a look at crests and troughs. The top of each wave, that's called a crest. The bottom is a trough. The distance between 2 crests or troughs is called a wavelength. The tape is our center line. If we measure from this center line to the top or the bottom, that will give us our amplitude. The more energy the wave has, the higher the amplitude will be. Watch this. If I transfer only a small amount of energy to the sticks, it will have a small amplitude. But if I transfer a large amount of energy to the sticks, it'll have a higher amplitude and a taller wave. Examples of transverse waves include light waves, radio waves, and ocean waves. The other type of waves is longitudinal waves. In a longitudinal wave, the particles of the medium vibrate back and forth parallel to the direction the wave is traveling. Again, that's a complicated definition. Here's what it means. Instead of moving up and down like a transverse wave, these waves move back and forth. If a wave is traveling across, the particles also move across. Sound waves are longitudinal, so is a Slinky. I'm going to use this to show you how sound waves work. When I give the end of the Slinky a push, You can see places where the links move closer together and places where they move farther apart. Notice how the Slinky isn't moving. The end stays in place, but the energy is transferred from one end to another. When sound is produced, the longitudinal wave travels through the air in compressions and rarefactions. They enter your ear. These vibrations move your eardrum, which begins the process of you being able to hear the sound. The close together areas are called compressions. Rarefactions are where they are farther apart. You can find the wavelength by measuring the distance between two compressions, or between two rarefactions. I hope you learned something about parts of a transverse wave and how longitudinal waves travel, and how tasty Sour Patch Kids are. Until next time, stay nerdy. Roll the outro.